Welcome to The Explainer. Today, we're going to graduate from just managing single containers. Instead, we're becoming city planners in the wild world of Kubernetes. Let's build our very first powerful, orchestrated container city. So, if you're coming from the world of Docker, you're probably used to thinking about and managing these individual containers, like single boxes. And it's great, it's powerful. But what happens when you're not dealing with one or two boxes, but hundreds or even thousands of them? Well, you can't just stack them up randomly. You need a city planner, right? A system of organization, an orchestration environment. And that right there is exactly what Kubernetes is. Okay, let's just dive right in. Here's our game plan for today. First, we're going to talk about why Kubernetes even has this idea of a pod. Then we'll dissect one to see what it's made of. After that, we'll get our local labs set up, we'll deploy and then debug our very first app. And finally, we'll take a peek at what's next with deployments. So in our container city, we don't just, drop containers wherever we feel like it. Kubernetes has a very specific fundamental building block. It is the absolute smallest thing that Kubernetes can create and manage. And this little unit is called a pod. Now, the best way to think about a pod is as a kind of logical host, or maybe like a tiny house for your container. You see, here's the key. In Kubernetes, you don't deploy a container directly. You always place it inside of a pod first. And this picture really says it all, right? Instead of writing these super long, complicated command line arguments like you might with Docker run, a pod uses a declarative YAML file. And this file spells out exactly how its container, or containers, should run. It's literally like having a blueprint for the house, which makes all your configurations standardized, repeatable, and just so much easier to manage. Okay, so we know we have to put our containers in these houses called pods, but why? What are the actual advantages? What does this house really provide for the containers that are living inside of it? So here's the magic. The absolutely crucial point is that everything inside a single pod shares the exact same environment. They share a network, they can share storage volumes, and the entire pod gets one unique IP address. This design, well, it allows for some incredibly powerful patterns, especially when you start putting more than one container inside a pod. For example, because they share that network, two containers inside the same pod can just talk to each other using localhost, almost like they're two processes running on the same machine. They can also share files like it's nothing through a shared storage volume. This is absolutely perfect for patterns like sidecar containers, where you have a little helper container that supports your main application. Now, to start building in our Kubernetes city, you don't need some massive, expensive cloud account. Nope. You just need two essential tools, one to act as our command center, and another to build a little practice model of the city right on our own computer. And getting set up is way simpler than you might think. Kube-control. Think of it as your universal remote control. It's the command line tool you'll use to send instructions to any Kubernetes cluster, anywhere. And then there's Minikube. Minikube is awesome because it sets up a free, local, single-node cluster right on your laptop. This means you can learn, experiment, and deploy without ever worrying about a surprise cloud bill. All right, tools are downloaded, our local cluster is humming. I think it's time for the main event. Let's deploy our very first application and bring our first house to life in our little Kubernetes city. The basic workflow is actually super straightforward, and it's something you're going to do over and over again. First, you define everything about your pod in that YAML file. That's the blueprint. Then you use kube-control to hand that blueprint over to Kubernetes and just tell it to build. And finally, you use kube-control again to ask, hey, is the pod up and running? So that's the happy path. But, as anyone who's ever written a line of code knows, things don't always work perfectly on the first try. So when your pod isn't running the way it should, how do you figure out what on earth went wrong? Your first go-to command for debugging, every single time, is kubectl describe. Think of this as the status inspector. It gives you a detailed report straight from Kubernetes itself. Did it have trouble pulling the container image? Did it fail a health check? The describe command basically tells you the pod's entire life story and, more importantly, where things went off the rail. Okay, but what if the describe command says the pod is running just fine, but your app is still misbehaving? That's when you need kube-controlled logs. This command is like an application microscope. It lets you peer directly inside the container and see the real-time output from your actual application code, which is, of course, absolutely essential for hunting down bugs. So, we've done it. We've built and debugged our very first house. That's a huge step.
But in a real production-grade city, a single house is pretty fragile. What happens if it collapses? In our setup right now, nothing. It just stays broken.
And this is a really, really crucial point. Pods are almost never used directly like this in a real-world production environment. They're the fundamental building block, for sure, but on their own, they're missing those big enterprise-level features we need, like auto-healing if they crash or auto-scaling to handle more traffic. For that stuff, we need a higher-level concept that manages the pods for us.
And that concept is the deployment. A deployment acts as a supervisor or a manager for your pods. You just tell a deployment, hey, I want 3 identical copies of this pod running at all times. And then it becomes the deployment's job to make sure that's always true. If a pod crashes, the deployment automatically creates a new one. This is the key to building resilient, scalable applications in Kubernetes. And that brings us to our final thought for today. Pods are the foundation. Deployments make them robust and self-healing. But what about managing change? How do we update the application that's running in all those pods to a brand new version without any of our users noticing a single blip in service? Well, this is where the true power of orchestration shines, and it's the very next step in our Kubernetes journey.